Okay, go. I'm out of your way, and we'll be watching.
Get your lectures done, Mock. You can play with those later. Mommy, I'm ready to go.
Welcome back to science class. We're going to look at our homework answers and then also at the answers that you completed during the homework check time. So let's start right out with the homework. Michael, you can come on up for number 4. Differentiate between the experimental group and the control group.
The experimental group is when the test is performed, and the control group is a standard for comparison.
Right, so the experimental group is the group that the test is performed on. Exactly, good. Tommy, give the term for the factors in an experiment that are the same in both the control and experimental groups.
Constants are when differences are the same in both the experimental and control groups.
Okay, I don't think it says differences, though. It says factors. That's talking about the different things in the experiment are the same. Good. And number 6, define variables.
Variables are the differences in both the control and experimental groups.
Exactly. Good. Thought provoker number 1. Which step of the scientific method should be done all the way through the experiment? And again, these thought provokers are ones you have to think about. So you won't find the answer just spelled out necessarily in your book. What'd you put?
The step that should be done throughout an experiment is to test the hypothesis by experimentation.
Well, you know what? Once you do have a hypothesis, you'll want to test it. But before you have one, you can't test it, can you? But there's one of those steps that you would need to do all the way through.
Observe.
Probably not testing or drawing conclusions, but one that we said before that a good scientist always is doing this all the time. You remember?
Observing.
What about analyzing? Well, not so much analyzing, but recording the experiment, and then once you get enough material recorded, you can analyze. So if you put it down as record and analyze, then that's fine. That's something you can do all the way through. Those watching, did you have that? How many students had that down? That is one you had to think about. Okay, good, and you can correct that and you'll be just fine. Number 2, if another person repeats your experiment, how should his results compare to yours?
They should be similar.
Because he does the same thing that you do.
Right, they should come out the same. Exactly. Thank you very much. The question that we worked on at the beginning of our time, it says, when testing a hypothesis, why must you only use one variable, Mary?
When testing a hypothesis, you should only use one variable because the conditions of all the groups might be different.
All right, if the variable is the thing that's different, isn't it? But if you have more than one thing that was different, would you be able to put your finger on the cause of your final result? No, you wouldn't. If you had several variables, you would not know which one of them caused the result. And that would be a big problem. Good. Thank you. So as you're working on these, make sure you're thinking about these questions. They'll help you to learn the information as you think about it. And speaking of learning information and what you learned and so on, we're going to be taking a quiz. And this is a little bit different type of quiz than the one we had last time. This quiz is already printed out for us. So you need just one sheet of paper. And a pen and a pencil. And the one sheet of paper that you need is for your cover sheet. Everything else should be underneath your desk. Students watching, please prepare for the quiz. One sheet of paper, pen to write with, and then a pencil to grade with. Again, make sure you are using your cover sheet. I'll be passing these quizzes out, and then as soon as you receive yours, you may begin working on it. And we'll just pass these right down the row. If you have extra ones, just pass those back up front. And I will come back by and pick those up. Of course, make sure to put your name and the date on your quiz. That's important. Is there anyone that did not receive one? Any extras, just pass those back up. Thank you. And you'll have just a few minutes to write these down and record your answers. Please do remember to use your cover sheet.
It's the study of living things.
Thank you. Don't forget your cover sheet. David, let's remember to use your cover sheet. You don't have another piece of paper? We'll fold that down. Fold the top of it down as you go. There you go. If you're uncertain of a particular answer, go ahead and do the other questions and come back to the one you weren't certain about. Remember that spelling does count, so it would be important to be careful to spell your words correctly. When you are finished with your quiz, if you will just sit quietly, please don't take other things out. Just sit there at your desk. Who needs more time? Okay, a couple more minutes. When you are finished sitting there and waiting, just put your cover sheet over top. Few more seconds. might be finishing up your final answer there. Now, remember how we exchange when it's time in a minute. We're going to put the pen and the cover sheet off the desk, and then we'll pass either forward or behind like we did last time, and do that without talking. Students watching, your on-site teacher will direct you on the right way to pass your quiz for grading. And let's go ahead and do that, please. Put your pen and your cover sheet off your desk. Make sure you have your pencil. Pass your paper to the person in front, please. If you are in the front, just walk carefully to the back with your quiz. Sign your name at the bottom as grader. We always do that. Then listen carefully to these answers. If it's wrong, put an X by it. If it's misspelled, -1 for those at the top. Number 1 is biology. biology, biology. Number 2 is coral reef. Or if you put coral by itself, that would be fine, C-O-R-A-L. And I think it's fine also if you just put reef, R-E-E-F. So coral reef or coral or reef by themselves. Number 3 is false. That was a false answer. Number 4, metabolism, M-E-T-A-B-O-L-I-S-M, metabolism. Number 5 is botany, B-O-T-A-N-Y. Down at the bottom then, the letters, listen carefully. Number 6 was D, and then it goes B as in boy, C, A, B. Listen again for those. At the bottom, D, B, C, A, B. These are going to be 10 points for each one that's missed. So subtract up in the upper right corner and then put the score. Remember to count -1 for spelling for the ones up at the top that were spelled words. So 10 each, 1 for spelling. Show your subtraction and then carefully figure the score. And let's go ahead and return that to the owner. Owners, when you've seen it, then pass it forward. And we will pass those and collect across the front just like we did last time. Students watching, your teacher there will give you directions. All right, so this side will go past this way, this side will pass this way. Pass those forward quickly. And let's go ahead and have your books out. How'd you do? Did we do well? Hope so. It's a good idea to keep track of your scores so that you'll remember how you're doing. That's very helpful. I would write down the score you just made. So let's have our books out, and then let's have those books closed up on our desk just for a minute. We can go ahead and pass those across. And we're going to think back to some things that we learned last time. And let's start over here on this side. Let's pass the mic over so Kenny can be ready. But first we're going to have a question for students watching. Who's the father of the scientific method? Now, Kenny, let them answer and then we'll let you check it for them. Who's the father of the scientific method? Okay?
Sir Francis Bacon is the father of scientific method.
He is. Wonderful. Good. And we said the scientific method, obviously just a way to do science, to learn scientific information. We said that there are 3 main parts of the scientific method. Nicole, give us one of those.
Improvising?
Well, hopefully scientists don't have to do that too often, but you know what? You're on the right track. The words are very similar. What about when they come up with a possible explanation? Or
Hypothesizing?
There you go. That's the word you were thinking, I believe. What's another aspect or part of the scientific method, Sean?
Observing.
It is. Very good. And Dixie, what's the last part of the scientific method?
Experimenting.
Exactly. Good. Pass it over to Heidi. Students watching first, however, what do we call a sensible explanation for a scientific problem? Okay, go ahead.
A scientific method?
Well, we're going to use the scientific method to determine if our sensible explanation was right or wrong. But what do we call this sensible, possible explanation for a scientific problem?
I have a hypothesis.
That's it. That's a mouthful, isn't it? Gathering data, Josh, what do we call that? Often we use our eyes to do this, but we can use other ways of gathering data as well.
Observing.
Exactly. Good. Wonderful. And if we're going to find out, Michael, if our hypothesis is correct or not, we will conduct... We may conduct a test, or we call that...
Experiment.
A law?
You always picture scientists doing these things. In your mind, a scientist is a guy with a white lab coat and a beaker in his hand, and he's doing a what?
Hypothesis?
Well, he probably already did that. Class, help him. What's he doing?
Experimenting.
Right. There you go. Good. And that's a very important scientific method. Now, we learned last time that with those 3 parts of the scientific method, we end up with 6 specific steps. Nina, do you remember the first one?
State the problem.
Exactly. Good. And then, Micah, what's the second step of the scientific method? Students watching, you be saying the whole list there while Micah's thinking. Turn sideways there a little bit, Micah, so folks can see you while you're thinking. State the problem. Now, you can't go very far to figuring out the answer to your problem if you don't know anything about it. So step 2 is to gather information. Exactly. Good. Passing on over to Manissa. After we've gotten some information, then we can probably come up with an explanation or a class helper. Turn sideways a little bit. What's that explanation called, class? Hypothesis. Right, so we formulate one. Now, you know, this sounds hard because it has big words, but that doesn't mean it's hard. It's just think about this. After we have a hypothesis, step 4, we're going to do what, Cody? Remember, we're a scientist, so we probably have our white lab coat with our beakers and things, and we're doing an experiment. Good. So test the hypothesis by an experiment. Then, Tatiana, while we're doing the experiment, but all the way through, we need to do this. Turn sideways. There you go. We're going to write things down, right? Remember what that was called? Let Kaylin help you. Students watching, too. I bet they've got it.
Record and analyze.
Excellent. Record. What's that second word?
Analyze.
Analyze. Good. Wonderful. And finally, Willow, we can state when it's all finished and we decide in our mind how it turned out.
Our conclusion.
There you go. Good job. Yeah, these are hard just because the words are big and not as familiar for us. Let's go over here to Benjamin. Students watching, they'll get an opportunity while he's getting the microphone. What do we call, and again, this definition sounds like it's something really hard, but it's one of the things that you know, a way of explaining an object or event by using a set of facts. A way of explaining an object or an event by using a set of facts. Students watching, what is that?
Hypothesis.
Benjamin, you remember? Sounds hard. After we have a hypothesis, and based on all the information we have, and others agree with us too about this, we no longer call our idea a hypothesis, but
a law.
Well, we can't quite go all the way to the law yet. This is kind of part way between hypothesis and law. Let's let Natalie try it.
Nope.
A theory?
There you go. Good. Back to David. What do we call a theory that's never been proven false, David?
That's a law.
A theory?
Well, Benjamin helped you a little bit with it. A theory that's never been proven false. Like we have one of these for gravity.
It's the
You jump off the building, you're going to hit the ground every time. What do we call that? Class, help him. Law of science. There you go. Good. Let's all open our books up. Page 16. Page 16, applying the 6 steps. Remember, in review, every time we have it, each student here needs to answer in their mind every question. Students watching, answer every question in your mind. Pretend it was a quiz every time we have review. And then when it really is a quiz, you'll do great. All right, page 16, applying the 6 steps. Now, remember last time we were looking at the snails on page 15, and we talked about that experiment. We're going to go through it again a little bit and see how the 6 different steps of the scientific method apply to this snail experiment. All right, so the first step of the scientific method, we're going to move over here to the board so we can put these up as we talk about. The first step of the scientific method, class, is to state the problem. Good. All right, now. When we state the precisely, now, by the way, you may be thinking, well, Ms. Stansel, my problem is, problem we mean something in science that we want to know. That's what a scientific problem is. Something in science that we want to know. Look at your example in your book with the snail experiment. The problem there was, are snails more likely to travel on a smooth or a rough surface? And you say, that's not a problem, that's a question. Well, you know what? The problem is often stated as a question. And here it was. Remember looking back on page 16. Are they more likely, or back to page 15, are they more likely to travel on a smooth or a rough surface? That was the question the person wanted to answer. And in science, we call that a problem. All right, then next, in order to learn about the snails and what might be their possible answer to this problem, we need to gather some information. So that was step 2. And so the person did some research about snails and found that they crawl along on slime trails, which are probably pretty smooth, and learned some other things about it. And now they're able or ready to do the next step, which is to formulate what, class?
Experiment.
A hypothesis. Good. And a hypothesis, Sean, is a sensible what? It is a sensible explanation for the problem. And that is the next step that we're going to need to do. So, Sean, next time, remember to use the microphone, but we got it. It's a hypothesis, a sensible explanation for it. Now, so the person decided, look in your book. The hypothesis the person decided to make was that snails are more likely to travel on a smooth surface than a rough surface. That's what they thought based on their information they had gathered. All right, then it's time to do what with the hypothesis, class? Experiment, or when we do that, we're testing it, aren't we? Good. All right, so we're going to test the hypothesis. Now we need to learn some new things. When you're doing the test or doing the experiment, there are certain important things you need to remember. And so we're going to put some of these on the board, and again, we're going to be referring back to page 15 and looking at that experiment and seeing what is the right way that a scientist does an experiment. It needs to be very precise and accurate. You'll be doing science projects in future grades, and even in this grade, you'll be doing a portion of a science project. So this information is really practical. Students watching as well, this will help you tremendously as we go through. You want to make sure that we all understand how this works. So we're going to test the hypothesis. So flip back to page 15, and I'm going to put some little sketches on the board, but since I can't draw that beautifully, let's have you looking in your book so you know what it is that I'm drawing in case it's not real clear. All right, notice on page 15 we've got 3 groups of snails there. All right, so group 1 was crawling on a smooth board, right? The board was smooth all the way down. And this one was called group 1 in your book, or actually not that. Let's erase that. That one was called the control group. It's the first one in the picture, but it didn't have a number with it, did it? So we'll get that fixed. This one was called the control group. And we'll write that word on here. And the board was smooth all the way down. It was smooth on this end. And it was smooth on the other end. Smooth board. All right, but look at group 2. On that group, you had a board that was smooth on one end, but it was rough on the other end. So we have something a little different here. And this one was called Experimental Group 1. Experimental Group 1. Okay, so this is experimental group number 1. All right, then we have experimental group number 2. It was smooth on one end, and it had sandpaper on the other end. Now, how many have seen sandpaper? Well, all of us have, students watching, if you've painted or whatever, you've used it. So it's really rough, right? How'd you like to take a bath with sandpaper? That would not be good, would it? Not be good. All right, so sandpaper is very rough, but the board, on the one end we're smooth, but on this end we're very rough. All right, so we've got 3 groups. This is experimental group number 2. I'm not going to rewrite experimental group and all that, but now we've got it all set up. So what is the situation with this experimental group, control group? What's the purpose of all this? Well, let's look back in your book on page 16 now. What does it say for an experimental group? Notice it there. A group on which a test is performed. Okay, well, that's true. We are doing a test on this group and on this group. But what about the control group? Notice the definition. It says it's a standard for comparison. Just that word comparison is the key. What's the control group for? The control group is to compare the others to it. When we test the snails in group 1, we're going to compare how they behaved to the control. When we test the snails in group 2, we're going to compare how they behaved to the control. So the control is a standard or something that we will compare to. You don't even have to say standard. It's just there for comparison. And that allows us to understand how our experiment turned out. Allows us to understand it better. Something else that's very important with these groups here, control groups, experimental groups, notice the next term, we have to have some things that are called constants. All right, and we're going to put that term up on our strip here. We have to have some things that are called constants. Notice there's an S on the end because there's more than one. Sometimes they're called constant factors, and you'll see that. All right, what does that mean? If something is constant, that means it does not do what, class? Change, right. Okay, so we're saying, and notice your definition, conditions that are the same in both the control group and the experimental group. So conditions that are same in all 3 groups would be constants. Your book gives you some examples. In all 3 groups, the snails would be probably in the same temperature, the same humidity, the same amount of light, the same type of wood was used. Why do you have to do that? This is important. Think, why do you have to do that? You have to do it to make it fair. It's not fair otherwise. What if on the quiz we just took, the students watching had to take a 50-question quiz, and the students here in the room had to only take a 1-question quiz, and the 1 question was, what is your name? Would that be fair? No. And you say, yeah, that's fair because I got the good end of the deal. But what if you're a student watching? You say, oh, no, that's horrible. That is not fair. Well, in science, we have to make it a fair comparison or it's not accurate. All right, so constant factors would include, yes, that's true. But there's a lot of other constant factors. Let's think. We need to name some. Students watching, can you name some of the other constant factors? I'll give you one to help you think about it. We would need to use the same type of snails in all 3 groups, right? What if we use land snails in group 1 and sea snails in the other 2 groups? You can't compare land snails to sea snails. Sea snails will probably die when you pull them out of the water, right? So you have to have the same size snails. What else? Or the same type snails. What else? Caitlin.
The same type of board for all three groups?
Same type of wood. Good. And Heidi, what else about the wood?
You have to have the boards have to be the same length.
Same length, yes. Wouldn't it be horribly unfair? Let's say that the experimental group here, number 1, let's say their board was only this long. And all the other groups were the length that I drew. But this one was only this long. Well, you would form a conclusion saying, well, snails prefer smooth and rough because they went right over that thing just real fast. And they got to the end of it. Well, that's because it was smaller than me. It's not fair, is it? And I know that teenagers are very all into fair, aren't they? Yeah, you're into that. So you know what it means here. Constant factors. We have to keep many things, everything the same, in fact, except for one thing. What's the only thing in all three groups here that's different among the three groups? Nicole, remember to tell us in the microphone.
The end of the board.
Exactly. The end is smooth in the control group. It's rough in experimental group 1. It's very rough in experimental group 2. So there's only one thing that varies between the three groups. What does vary mean? That different, to be different. All right, so we call that the variable. Now, we have an S on the end of this word here because when you do many experiments, you will have one variable in each. But notice, so variables are something that are important to know about, but each experiment should have only one variable. In a single given experiment, there should be only one variable. And here we have just one variable. That's very, very important. All right, now go on down the page there. Notice it says even with a single experiment, you cannot come to a hard and fast conclusion. You need to repeat it, then you need to do other related experiments. Every experiment, notice at the bottom of the page and going to the next page, every experiment involves comparing the results of at least one experimental group to a control group. And that will allow you to have accuracy. Now, there are some exceptions about needing a control group. Those are things you'll learn later on. The next step of the scientific method, remember, is to record and analyze, and we'll put that step up. When you record and analyze your experiment, then you're going to be able to determine if it turned out the way you expected. Was your hypothesis true or not? It may not be. That doesn't mean you're a failure in life. That means that there were just other things that you had not considered. And then finally, you need to state the conclusions. By the way, regarding recording and analyzing your information, remember that's something you do all the way through. All the way through, you're going to be writing things down and thinking about what you see. And then finally, when it's all finished, you should be able to come to some conclusions. Now look at the bottom of page 17. We have an experiment here. In fact, throughout our study of science, we're going to be doing some various experiments. And we're going to be working on this one in this lesson. And I've got some folks that are going to be helping with that, so they can be coming on up and just waiting over here on the side. This experiment is involving bean seeds. And what we're looking at is how does the water get inside of a bean seed? And Benjamin, if you'll get the light here, we want to take a look at a bean seed and see how they came up with the hypothesis that they had here. That's a huge bean, isn't it? Notice with the bean that right in the middle there appears to be a little area. And there appears to be a little dot on one end of that. So a person might think to themselves in doing their research and gathering their information, they might think, well, that hole could be the place where the water comes in the bean and helps it to grow so it can sprout. Or maybe it comes in through this little scar. This scar was actually like a little belly button where it was attached to the pod when it was developing. And a person might think to themselves when they were doing their research that this is where the water comes in. All right, so the problem is, how does the water get in a seed when it's sprouting? We've learned some information. We've now developed a hypothesis that it comes in through the little scar or the little hole that's beside the scar. All right, now we can do an experiment, can't we? All right, we've got 12 seeds here. And we need to get you folks to paint these seeds with fingernail polish remover for 6 of them. Not fingernail polish remover, but fingernail polish. All right, so you can each paint 2. And here's an extra paintbrush. All right, we're going to use that red nail polish there. Paint it right over the place where we thought the water came in, not the whole bean. Come on around this way. Josh, there you go. You can stand right up in there. As soon as you get it finished, hand it to me, and I'm going to put it on this little paper clip that's going to hold it up there. Okay, and the ladies got the brushes right now, don't they? Okay, thank you. So we're painting just over the place where we thought the water might come in. And we're going to have 6 seeds that are painted, and we're going to put them in some water, and then we're going to have 6 seeds that are not painted, and we're going to put them in some water. Now, the group that's painted, is that experimental or control, Sean?
Experimental.
Thank you, sir. Pass it to Kenny. The group that's painted, is that going to be the experimental or the control group? Uh-oh, you got it on your finger? I'll put a little more dab on there. We'll get it off after class. Sorry about that. That's okay. You guys don't like fingernail polish. I never cared for it either. It smells bad.
The experimental.
Yeah. Thank you, Kenny. The experimental group is the one we're painting. 1, 2, 3, 4, 5, 6 of them are painted. All right. Thank you. Y'all can have a seat. Yes, I'll lay that down so it doesn't get on the counter. Now we've got 2 guys that are going to measure some water for us. So if you guys will come up, and in our beakers we can put 150 milliliters. Now your book says a different amount, but it's just easier to measure 150 milliliters with the way these beakers are set up. So fellas, if you'll go to the side over here and use the faucet, take this one for Evan. Thank you. All right, now while they're doing that, I'm going to show you some that we set up earlier today with a different group of students. And we've got these labeled experimental group, and hopefully you can see how they have red fingernail polish on them. And you can see the control group does not. Let me try to get my hands out of the way. They don't have the fingernail polish. You can see the little bubbles. That's just the oxygen. And you can see that the beans appear to be changing. You might be able to see that. Now, we have to let it sit overnight to come back to get the final result. But the fellas are putting water in the beakers. And then we'll be able to put the beans in. We'll have to wait till the ones with the polish dry. So we'll actually be putting it in afterward. But then we'll show you next time how it turns out. All right, so notice we've got 150 milliliters of water in each. So what kind of factor is that, class? It's a constant. It's constant, right? Did we use different kinds of seeds or all beans? All beans. That's a constant factor. Same size beaker, same kind of fingernail polish, right? They're all constant factors. And we have our experimental and our control groups. Now, speaking of that, notice we're using some science equipment here. So we're just going to mention real quickly. Look in your book on page 18. Page 18, you've got to check it out there for safety in science. And by the way, on the left of that, you've got to tackle this. That's a great thing that you can do on your own to review these concepts. But look at the safety in science. Safety is really important when you're doing labs and working with science. It's important to follow instructions. It's important to know the location of safety equipment. It's important to handle glassware real carefully. It's important to wear protective clothing. For many labs, you need eye protection. You may need gloves to protect your hands. You may need an apron to protect your clothing. Those are all important protective features. Notice, looking down the list, it's important to follow all safety precautions in lab with equipment and chemicals. If anything breaks, notify the teacher. You don't eat or drink while you're doing an experiment. Even if you're in your home doing it, you don't eat or drink. You don't put your fingers in your mouth. You shouldn't even rub your face because you might contaminate something. Number 7, keep your work area clean. Clean up after your lab. Number 9, never perform any unauthorized experiments. Now on page 19, notice you have some things listed, some different science equipment pictured. And it's important to start learning what these things are. A flask is used in science for various experiments. Notice it has a narrow top. A beaker has a wide top. And both of these come in different sizes. And we've got a really big beaker here. Here's a graduated cylinder. This is used for very precise measurements. It's graduated, it has measurements on it. Test tubes are used for various experiments and many other pieces of equipment. Each one needs to be designed for the type of experiment that you're going to be doing with it. And we will be doing several types of things throughout our study here. All right, let's go ahead and take your assignment pad. Homework to write down. Read your textbook, pages 21 through 23. Read pages 21 through 23 up to 2.2 from pollen to seed. So read pages 21 through 23 up to section 2.2 that's called from pollen to seed. And then we're going to be beginning now to work in our science order and design activity book. And so you'll want to make sure that you have that. And we're going to complete in your science order and design activity book, we're going to complete activity 1 that's called word scramble. So you want to complete activity 1. Keep that right in the booklet. You don't need to tear it out or do anything like that with it. And you know what? These activities are going to be really a big help to you. They help you learn the information and review it. And so they're very, very useful. So hopefully you'll enjoy doing that. And we'll see you next time.
Students watching us, thank you for joining us again. Here we are in Lesson 5. I trust that you did very well on your first reading quiz. So you'll see the two types of quizzes we have, both review and reading, and you want to make sure that you're studying your homework very diligently. We're going to go ahead and take a look at our homework, and Sincere's going to help us out with number 1. Sincere, which city was the center of the great empire that rose up a few hundred years after Abraham's departure?
Babylon was that great city.
Was that great city? That's right. That rose up just a few hundred years after Abraham's departure. Thank you, Sincere. Number 2, who became king of Babylon and united all of Mesopotamia under his rule?
Hammurabi was the new king of Babylon and united all of Mesopotamia.
Very good, Kale. Number 3, who supposedly authorized Hammurabi to be a lawgiver?
The gods supposedly authorized Hammurabi to be a lawgiver.
Those are imaginary gods, right? Those fake ones. Good job. Number 4, Matthew, what are laws, and why is it important that laws be written down?
Laws are rules people follow in living together. It is important so people can't change the laws.
So they can't change the laws. Very good, Matthew. All right, and Noah's going to help us out with number 5. We do not want people just changing the laws on us. Number 5, did Hammurabi's laws treat the rich and the poor the same?
No, because they would decide different punishment if the criminal was poor or rich.
Poor or rich, boy, depending on your income bracket, was how you determine on whether or not what kind of punishment you were going to have. All right, and we know that that's just not right. We need to have equality under the law, which was one of those quiz questions as well. Go ahead and turn in your text to page 12. Excuse me, page 13. It would have been one and the same anyways. Put your pen there, close your book, look this way, and I want us to look up here at the board, and what we're going to do is point out another opportunity that we have. This is going to be called current events. And we're going to be doing one of these, roughly about one every, I don't know, maybe 5, 6 or so lessons. And this is how you should be heading your paper in current events. Now, I'll get into some other aspects of current events in just a moment. But the first thing you need to know is that, you're going to have an article. And what we would do is we'd like for you to attach the article to the 8.5 by 11 sheet of paper that you're going to turn in. Well, Mr. Smith, what if the article is on the computer? They're going to ask that, of course, you print that out. What if it's in a newspaper, that you cut that out or that you make a photocopy of that article? And we like for it to be the complete article. Sometimes on a newspaper, you'll see just a little paragraph about an article, and at the bottom, it'll say, see page 4D or whatever for the rest of the story. That also needs to be included in it. So what you could do is staple or paper clip that to the upper left-hand corner to your notebook paper. And then, of course, you would have your name on the top line like we would do for homework, and then the date of the article. I want to find out, wow, you got this current event, and this article was written 12 years ago. Is that current? No, that's not really current, is it? Not at all. So we want to see the date of the source. Then we should see proper bibliographic information, where you'll give the title of the article, you'll give the author's name, you'll give the source. Now, if it's your source, you're not going to say newspaper. What newspaper? Computer. Well, I don't care about whose computer it came from. You're not going to say the internet. You're going to say the website that it came from. Okay? So, that's what we mean by source. Then, you're going to write a 1-paragraph summary about the article. And after that, you're going to write a 1-paragraph about your opinion or your reaction to the article. That makes sense? Any questions here about how you're going to do this paper? Okay? Go ahead. Help us out. Please pass the mic.
Are we going to do it on little cards, or are we going to do it on a piece of paper?
8.5 by 11 sheet of paper. Okay? Is what we're doing this on. All right. Kale?
Are we going to have to present this by ourselves?
You have the opportunity to present this by yourself, Kale. That's exactly right. So you will present this information to your class. So in other words, you want to know this information. You're not going to get up here. Yeah, my current events about this stuff that happened when this stuff got involved with this other stuff. And, stuff was just happening. No, you want to know what your article is about because I may be asking questions about your article, okay? And your opinion needs to be something of substance. Well, this is what I believe because we're not attacking individuals. We're sticking to the article here. Now, your article that you find, it does not really need to be an article about crime. Just watching with us, we're not really doing articles on sports or the weather. I mean, what's going to be your opinion? All right, meteorologist says that with the heat index, it's going to be 110 degrees. My opinion is that you should drink water and not go outside, okay? No, that's not what we're looking for there at all. Crime. My article is about someone robbing the bank. You give a one-page summary, and my opinion is that it is wrong to rob. Well, I'm glad that's your opinion, but it's also biblical fact as well. Okay? Thou shalt not steal. So we're not debating biblical fact. We're not focusing in on heinous crimes. You got to understand that just because it's in the news does not mean that it's newsworthy. There are people that want to hear, quite frankly, gossip and frivolous news. I was looking up the news the other evening. True story. A lot of international conflicts taking place. Okay, I'm looking at this. On basically the home page of this news article, it talked about how a barber shaved a famous person's face in the back of someone's head. International conflict, the economy, unemployment, barber shaved someone's famous face in the back of someone's head. And it showed a picture of it. It was very good. We're not doing current events about barbers shaving people's faces in the back of people's heads. Okay? All right, so we got to look through the news to find what is newsworthy. In Lesson 9, you're going to bring your article to class. And in Lesson 10, you will actually have already now, on Lesson 10, you'll turn in both the article and the written portion. Okay? So Lesson 9, bring your article. Lesson 10, have the written portion along with that article. Now, you might be wondering, I don't know if this is a good article or not. So it's watching with us. You'll be able to ask your on-site teacher, is this a good article? Certainly, you come to me and say, listen, I know this is not due for another couple of days now, but is this a good article? What you don't want to do is wait last second and then the answer be, no, this is not a good article. I understand someone may have even shaved my face in the back of someone's head. Now, that might be an article I'm interested in, but it's still not newsworthy, okay? All right, let's go ahead and take out our textbooks. Page 13, your spot's still in that book. Looking this way, help me out. Students watching with us, give you an opportunity to answer this one. What term describes worshipers of many gods? You're thinking of the term, and the term is, that's it, polytheist. Students here with us, what term means worshiper of one God? Let's go with Daniel. You go ahead and please hold the mic and tell the rest of the class here.
Monotheist.
Monotheist, okay? Because mono being one. I'm putting myself in place of or above God. That means I practice humanism. That would make me a humanist. And remember, that's what the Sumerians were, as they were just giving human characteristics to their fake gods. Who can remember the name for the god of the sky? the god of the sky. DW, help us out with that. Tell the rest of the class.
The Sumerian god of the sky, who was supposedly the king of all the other gods, was named Anu.
Anu. DW, stay with me for just a second. You're so quick there. DW, who was the moon god?
Nana.
Well said, DW. Well said. Who was the Sumerian king that supposedly got these laws from the gods? Who's watching with us you're thinking of? Rather long name. That's it. Namu. Okay, Namu. And of course, they were offering no hope, the Sumerians were. Come worship our many fake, false, imaginary gods that have the petty problems that humans have. Abraham's God, the one true God, God Almighty, was to offer that hope. Abraham was to leave that land. You may remember the land of around the year 2000 BC. And that father of the nation of Israel is to provide an alternative to the pagan world and say, come worship the one true God. We're in our text here at page 13, you're looking there now, and we're going to be introduced to some new terms. And we know that history is all about terminology, really any subject is. And this says a few hundred years, so a couple hundred years, perhaps 200 years after Abraham left Ur. Christian historians, we need to be mathematicians as well. Help me out. If it's about 200 years after Abraham left the land of Ur, then circa, approximately, what year are we talking about right now? Just watching this, you're thinking about it. Kale, give it a try. Stand up and tell the rest of the class over here. Around the year?
Circa 2000 BC.
Well, if Abraham left the land of Ur in 2000 BC, and this is a couple hundred years later, then what year is it?
Circa 500 BC. 2500 BC.
Okay, well, you just went backwards in time, because if it's BC...
1500.
Okay, approximately around 1500, okay? So just a few hundred years, probably more around 1800 BC. Thank you, Kale. You're getting us into that ballpark there. I appreciate that. All right, a couple hundred years, approximately about 1800 BC, the city of Babylon became very, very important. We're going to go ahead and take a look at our map here, and we'll see the city of Babylon. Now, before we look at our map, I want us to think about this. Where is Babylon located in the bigger scheme of things? Where is Babylon located, really? Kelly, help us out. Good.
Mesopotamia?
Mesopotamia, Kelly. Mesopotamia, wait, Kelly, is the land between what two rivers?
The Tigris and Euphrates.
And the Tigris and the Euphrates. Very good. Okay, so we know that that is approximately the area that we are really looking at here, okay? And we see on our map Babylon. We'll go ahead and point that out right here. It is in that southern portion. Do you remember, students watching with us, what we're kind of referring to this southeastern portion as? The plain of Shinar. Okay, all of these places are coming into play. All right, so we're talking about Babylon, and we begin to see Babylon, looking at the map, begins to take over some other cities. Now, some cities are going to be a little bit more resistant to that than others, but other cities might fall right in line. Now, students with us here, help me out. What term do we now use to describe the taking over of one city over other cities? What term? Sincere, help us out. This was in our homework. Go ahead and right there, tell them. Can you think of some great nations in history? If I said the word Roman, you would say the Roman Empire. Okay, that's right. Thank you. The empire. We're not talking about the Roman Empire as of just yet. We are going to be talking about the Babylonian Empire. And we're going to see on our map here that a lot of this is going to be referred to collectively as, well, Babylonia. And so I'll go ahead and put that term on the board, Babylonia. We're kind of thinking of the land of Babylon, okay, or that Babylonian Empire as well. Babylon, a lot like Egypt, really, has served many times as an example, unfortunately, of worldliness, of paganism, of a culture whose foundation was really founded in ungodliness. It served as an alternative to a godly obedience and faith. Now, before we continue to follow Abraham, we're going to park right here for just a moment and begin to look at Babylon. Now, you may recall that I don't know if we really used the word empire, but the first city that really showed its influence was the Sumerians, correct? Okay, that's Sumerians. Even though the Akkadians came in, their culture was so dominant. Now we're speaking of Babylon. That Sumerian empire that centered at Ur ended around 100 years after Abraham left. Isn't that amazing? You think about that. God calls Abraham out of the land of Ur in the year 2000 BC. It was sophisticated. It was everything he had ever known. And you've got to remember that people were living a long time, well into their hundreds at this point. Still, okay? Hearing someone, I should say, that was 100 years old was not that unheard of. And if we said Abraham left around the year 2000 BC, he could have said, "Oh no, this is all I've ever known. I'm just going to stay here. I've got my comfort here." What happened 100 years later? Ur was taken over. That empire collapsed. Students, God knows what He's doing. Do you believe that? God knows what He's doing. Do you trust that when it comes to your life? Abraham certainly did. Now, Babylon, absolutely it had its influence. We're going to go ahead and take a look on our map here, however, at two cities that were just kind of stubborn in the sense that they were holdouts, okay, some strongholds, and it was important for Babylon to be able to get the cities of Marai and Larsa here. In fact, I'm going to go ahead and put those two cities up here on the board. And Babylonia really would not be truly complete. Why would it not be truly complete without these cities? Well, I want us to use an example here for a moment. We'll go ahead and use DW, okay? You know what? We've been using Joseph as a king, correct? We'll use you again in a moment here, DW. Joseph is our king of Smithopolis. But Joseph, and students watching with us, you may be part of this as well. There are some citizens in Smithopolis, Joseph, that they're not real happy about this. Oh, they may have supported you initially. Okay? They may have supported you initially. But now they're saying, no way. Well, let's say that DW is leading in some of this resentment toward Joseph. DW, I'm over here, buddy, okay, is leading in this discontent of Joseph. So Joseph's over here, and you know what DW's doing? He's stirring up strife. Boy, Joseph, this isn't good. We really need to get them on board. Now, really, let's expand this illustration to say they never really were part of Smithopolis, but we want them to be part of Smithopolis, okay? Now the plot thickens a little bit. Oh, they're outside our city walls, but you know, we go outside our city walls, we have to worry about the DWites and his followers and causing trouble. We're going to find some common qualities in great leaders. I didn't say good leaders, I said great leaders. When I say good, I'm speaking of morally good. Okay, great is just in terms of success. And you're not necessarily moral just because you're successful. Great leaders, successful leaders, they find a way to unite the people. We're going to see that in Egypt. We're going to see that in Greece. As long as there are those that have discontent, the possibility of a rebellion exists. And we are now going to have a leader here in Babylon that is going to emerge, and he is going to be able to lead the way in the uniting of the people. And of course, I am talking about the leader of Hammurabi, okay? So you want to make sure that might be a name that you've heard before. It might be a name that you're not that familiar with. But I'm going to go ahead and put him on the board, and Hammurabi. And you can just guess that Hammurabi, what does he want to do? Well, he wants to try to get Larsa here in part of Babylonia, okay, to try to get them to unite the people. This took place around the year circa approximately 1800 BC. So we're looking at, again, a few hundred years after Abraham's call. Now, your book points out some qualities of Hammurabi. First of all, it says in just 31 years, this extraordinary leader conquered the surrounding kingdoms and united all of Mesopotamia under his rule, meaning he was able to get those two cities. Now, we'll talk about how that happened in just a moment. Another quality of a successful leader is his ability to hang on to a very large empire. What are the dangers, the disadvantages of having a very large empire? Yes, go back here.
Because Hammurabi.
Or not even Hammurabi. What would be the disadvantage of having a large empire?
Okay, so if someone has like a big empire to rule, they have different cities, and with all those cities there can be many rebellions.
In other words, they have to keep an eye on all of them, right? Very good. Thank you. That is exactly right. What term did our text use to describe the governing of all of these people? The term is bureaucracy. And I'll go ahead and put that on the board. And you know, really, in layman's term, you know what bureaucracy is? It's a babysitter. Okay, we're looking at the term bureaucracy, and we're defining it. An organized group of people appointed by a ruler to help him govern. So, mom and dad are going out for the evening. They have probably not a group of people. If they have to have a group of people, you and your siblings are really bad. All right, we're bringing in the National Guard. We're going to go out for dinner for the evening and watch my kids here, okay? So they'll bring in someone that they have appointed to assist them. Correct? All right. So you just let mom and dad know that they have a bureaucracy when they go out for the evening. It may be that at some point you become of age where mom and dad appoint you to be the bureaucrat over your house. Okay? We're leaving now. and we are putting Beth in charge of all of her siblings. Okay? All of her sisters, she is in charge. Matthew is in charge of the house while we are gone. Okay? That's what's happening. And think about the advantage. Joseph, now, not only were you able to unite everyone, right? This is good. Now Joseph wants to know what's going on over here. What's going on over here? He doesn't know. We're going to go ahead and say the first person in each row has been appointed the bureaucrat. Okay? The bureaucracy, that organization. So Sincere, you are our bureaucrat, and you know what you're doing? You're keeping an eye on people over here. Matthew, Noah, Cole. Okay? You're keeping an eye, and you're making sure that they're doing what's right, and you are going to go report to Joseph. Daryl, you're keeping an eye. Keep an eye on that Hannah right there. All right? Just because they wear pink doesn't mean they can't rebel. Okay? My daughters wear pink. I think they've tried to overthrow me once or twice. Fortunately, I still have size on them right now, okay? So, listen, in your reporting, hey, King Joseph of Smithopolis, you know, we think Grace over here might be trying to start something, and it helps you out. I mean, I guess after all, Joseph, eventually you'll find out, but it might be too late, okay? So that was effective. I said you could be successful, but not necessarily be moral. Well, that wouldn't be being successful in God's eyes, would it? We said he united. One of the ways that he united is writing letters to those cities like Larsa and Marai that were not completely on board. And he said essentially, let's be allies. Let's be best friends forever. Oh, okay, this is nice. We're being friends. What he was doing is he was lying. And when they weren't expecting it, he then came in and he took them over. So be careful who your friends are. Scripture is full of verses about that. Go ahead and turn your text, page 14. There were a lot of good things taking place. Sure, absolutely, in Hammurabi's empire, the Babylonian Empire. Your book points out living conditions improved. Businesses were doing well with constructions of highways, bridges, improved canals, made more land available for agriculture. But he is best remembered for his laws. Put these laws, carve them into a pillar about 6 feet high. I'm 6 foot even, so that's how tall this pillar is. And we know from archaeological excavations in having uncovered this pillar that there's a picture at the top depicting Hammurabi receiving the law from the gods. Well, now suddenly, again, using politics as a tool, you disagree with the king, you're disagreeing with God. Under this pillar were written laws. This was really groundbreaking. First, you had to have laws, and then you had to have cuneiform, correct, or written language, so that we can promulgate our laws through promulgation. Let's have the rules written down. I remember a Major League Baseball game in which a team, it began to rain, and the ground crew brought the tarp out, and the tarp was messed up. The ground got soaked. They were not able to play it, and the opposing team said, well, we want a rematch. We don't think the game should be called off. And they brought it to the authorities in Major League Baseball, and they cited a rule in the handbook, the baseball handbook. I think it was maybe Rule 4.13 or something like that. And it said, if the home team has a mechanical failure in something that does not allow the game to continue, that opposing team could essentially request to not replay the game from the beginning, but pick it up where they left off a few days later. That's a rule. It says it right there. Was the tarp a mechanical failure? Absolutely. Can you think of some other written laws? God's law, the 10 Commandments, the speed limit. Police officer pulls you over. You're driving down the road, you see those sirens. pulls you over and he knocks on your window. People always do this when a police officer knocks on their window. Who else would they want? So you roll your window down. Now, the officer goes, do you know how fast you were going? 85, 90 tops. Do you know what the speed limit is? Probably around 85, 90? No. It's 12. It was back there on the speed limit sign. Oh, I thought that was just telling me what time of day it was. No, speed limit, okay? There you go. We see it, we know it. And we do this with our laws. He had over 300 laws carved in. And we define these laws as rules people follow in living together. You know what that tells me? Laws are here for our benefit. There's a law that says you have to stop at a red light. That's very good when I have a green light and I'm going through the intersection, right? The stop sign is a good thing. We got to get out of this mentality of thinking all authority and all laws are here to punish us. No, quite the contrary. Authority and laws can be here to help you and to protect you. We like rules. Who likes the rule, thou shalt not steal? I don't want things stolen from me. Who likes the rule, thou shalt not kill? I don't like being killed. Or I imagine I would not like being killed, okay? So promulgation, making the laws, no. Now we got to understand that these were imperfect laws. We need right and just laws. Not just laws, but we need laws that are just. His laws were did not have equality. Oh, if you were rich, you might get a less punishment because of a bribe or something he could get from you. That was wrong. He put more emphasis on the material things than on the sanctity of human life as well. Equality under the law says that all people who commit the same crime should be punished in the same way. Now here he again begins to use religion, and we're at the bottom, page 14. It changed little, that Sumerian culture, into that Babylonian empire because of their use of these fake gods. The invading people adopted more gods. For example, the Sumerian goddess of love, Inanna, was just later renamed Ishtar. One important change, however, very important, was the fact that now they had a chief god. We talked about the fact that Hammurabi was receiving the law. That was from the sun god of Shamash. But now there's to be a chief god called Marduk. He was to be in charge of all of the other gods. And this change did much to elevate Babylon over all of the other cities. Our imaginary god's better than your imaginary god. Well, imagine that. Hammurabi's empire would collapse. He ruled for 42 years, and this is what we're going to find. The problem with many empires is that after they die, you have weak successors. The kings were unable to hold on to it, and by the year 1500 BC, even the city of Babylon itself had collapsed. It was not until the year AD 1901 that we began to find remnants of this once mighty empire that existed without God. And we see the results of it. Go ahead and take out your assignment pad. For homework, you were to read History of the World, pages 15 to 16. Read History of the World, pages 15 to 16. On page 16, answer questions 1 through 5. Page 16, answer questions 1 through 5. Bring your news article for your current events in Lesson 9, and current events are due in Lesson 10. Also, just by way of another reminder, don't forget about Geography Project in Lesson 8. A lot of things coming up. We're looking up here at the board one more time, knowing that area really of Mesopotamia and just outside those rivers became known as Babylonia. Hammurabi, his extraordinary ability to be able to unite the people, sometimes through deceit. He used bureaucracy to be able to keep an eye on everyone, and certainly the promulgation of those laws, of having them written down. Unfortunately, we saw that they were not equal in their justice. I trust that you're going to continue to do well in your homework, work on these long-term projects, current events, and geography projects, and just stay ahead of the game as we are becoming students of history.
You don't have a name yet. Tracy. Lyra. Jewel. Great. Was that a camera?
It's a camera. You want to take that?
Charger. Charger.
Take it.
Is that like a webcam, FaceCam?
Yes.
Cool. So that's what a lot of YouTubers use for when they have face channel. That's cool. I do want to set up my own YouTube channel, actually. I've decided on a name for it. I've contemplated everything, and I know what its name is going to be. I just need to upgrade